Hi, it's Mrs. Lemke, and I am here with you today to talk about how the tangent function gets graphed. And after we discover what the parent function of that looks like, and you should remember that a little from our computer activity on the first day of this unit. But after we rediscover what the tangent parent graph looks like, then we'll talk about how to graph variations of it. So you see here that I have a picture of the unit circle, and I have boiled this down to just a few values. And this particular picture is labeled with degrees, but I am going to think of those angles in radians because that's what we tend to do when we are studying to be ready for a calculus class. Calculus only uses radians, no degrees. So what I want to think about here are these different angle values and the tangent values at those angles. So if I were to label in a chart all the angles that are in this picture with radians, I would have what you see here. And now I'm just going to walk around the unit circle with you, and we're going to think about the tangent value at different locations. So recall that tangent of an angle is found by taking its sine value over the cosine value, which in terms of unit circle locations would be the y-coordinate divided by the x-coordinate. Okay, so when I'm here at 0 radians, I would take the y and divide by the x, and that would give me 0. And then as I move around the unit circle, here I am at pi over 4. If I divide these coordinates, which are identical, by each other, well, something divided by itself is going to be 1. And then if I keep going around, oh, wait, something weird happens here. I get 1 divided by 0. 1 divided by 0 is undefined, which means it is not an actual numerical value. There is no definition of what 1 divided by 0 is equal to in the real number system. So then I would keep walking around here and divide these, and similar to what happened at the pi over 4 or 45-degree angle, this is two numbers that are nearly identical, but one of them is negative. So this would be -1. And then here again, I would have 0. And then here I would have +1 actually, because a negative divided by a negative is positive. And then here I'm going to have that issue again with dividing by 0. And back to here, I would have -1, and then I'd be back to the start at 0. And so you can see that there is a cycling of values similar to what we saw with sine and cosine, but it looks like the cycling happens a little more frequently, right? This pattern, 0, 1, undefined, -1, is repeated right here. So it looks like it repeats every pi units. It looks to me like the period or the length of the cycle for this function is going to be pi rather than 2 pi. And this is the most commonly forgotten thing about tangent because our other two main trig functions, sine and cosine, are different from that. So that's something we're going to have to be very cognizant of relative to tangent. Okay, so let's go on now, and we're going to take those unit circle values, and we're going to look and see what our parent function is like. So the first task that we really need to think about is how to deal with these undefined values. So undefined is happening at pi over 2 and also at 3 pi over 2. So I'm going to choose, sorry, I do not know where to put this box. I'm going to choose to put pi over 2 right here. And that means that each of these boxes is pi over 4 on the horizontal axis. So each of those boxes is pi over 4. So that means that pi would be here. And if I take a peek back, that pi over 2 and 3 pi over 2 were asymptotes. Oh, I kind of spilled the beans there, didn't I? I said asymptotes. Okay, so undefined, the way that we're going to show that is by having a break in the graph. The graph is literally undefined. It does not exist at those locations. That's what undefined means, okay? And so the next asymptote or undefined location would actually be off the grid here because pi is here, and so pi over 2 would be like here if there was one more box. So it looks to me like there's 4 boxes that would equal that amount of space. So let's go 4 boxes the other way. 1, 2, 3, 4. Okay, and that would be negative pi over 2. Now let's think about our unit circle again. Negative pi over 2 is here, that much rotation. Is tangent undefined at that location? Yeah, heck to the yes, some of you would say. Okay, so negative 1 over 0 as undefined. Okay, so this makes sense. So on my graph, 4 boxes is going to be the equivalent of where you would find these undefined locations. I'll just sneak in a couple more just because. Okay, so that's what we've got going on so far. Now I know that my favorite number showed up. Do you remember what my favorite number is from other videos? That's 0, you're right. So I know that at 0, I have a value of 0. At pi, I have a value of 0. So at 0, we're at 0. At pi, we're at 0. And because I have this sense of this function being periodic, I know that that's going to keep going. Oh, look, these were 4 apart as well. Okay, so then I'm going to go back here. 1, 2, 3, 4. This location would also have a value of 0. And now there were some other values that had values of, or other locations that had values of 1 or negative 1. So pi over 4 had a value of 1 and 5 pi over 4. Pi over 4 is here. I'm going to make one vertical box be equal to 1 unit. Can I count by different things on different axes? You bet I can. Absolutely. Okay, and then 5 pi over 4, which would be right here, also had a value of 1. And look, 1, 2, 3, 4. Those are 4 boxes apart as well. 1, 2, 3, 4. Periodic function. Okay, and then there were some values at negative 1. So that was at 3 pi over 4, and I'm going to say it's probably back here, probably back here. Now, I don't really have to say probably because, look, this is actually negative pi over 4. Negative pi over 4 just means I went that much, right? This green arrow here, back. And I can see, indeed, the tangent value there would be negative 1. So I'm not really guessing, you guys, okay? I'm just putting that out there. I want you to have confidence in the things I'm saying, okay? So it looks like when I draw the tangent parent graph, I have 5 key locations. So just like with sine and cosine, you know how there were 5 points on each cycle? The tangent function also has 5 key locations. I wouldn't necessarily say points though, because 2 of the key locations are actually breaks in the graph, which is the opposite of having a point. It's having no point, okay? And it's a lack of points. It's a lack of definition. So we have 2 asymptotes plus 3 points, okay? That's still 5 things, so it's still kind of the same, but kind of different, okay? So asymptote, dot, 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 asymptote. Asymptote, dot, 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 asymptote. That is your cycle, okay? So as I look at this, I'm going to remember now back to that computer lab, and I remember that the graph had these little wiggles. Okay, and so this is how you want to draw in the shape of the curve. You want to hug that asymptote really closely, and then curve in to those 3 dots, and then hug the asymptote up at this top part. Hug, curve, hug, okay? Now, if I see on your paper, like if I asked you to draw a tangent graph and you draw something like that, where you're not really getting close to the asymptotes, that's going to cause me to wonder if your brain understands what the asymptotes do. Okay, the asymptotes are like scaffolding that the curve really uses to define its shape. So I do want to see, aside from the part where you are going through those 3 middle points, the tails should hug up to those asymptotes. Okay, that was my sound effect for hugging up. Okay, now we're going to find a color that matches that blue reasonably well. I think this purple. Okay, and we'll talk about domain and range and period and amplitude. Okay. One of the harder things to explain about tangent is the domain. And so the way that I like to think about this is to think, well, domain is what my input variable can equal. So I'm asking here, what kinds of angles have defined tangent values? And if you look back at your unit circle, the places that were the problem children, so to speak, were up here and here. Okay, so that's going to be your pi over 2, your 3 pi over 2. If you kept going around the circle, your 5 pi over 2, your 7 pi over 2. If you went in the negative direction, it would be these same values, but in the negative sense. Okay? So if you wanted to describe those in a short, succinct way, you would say they are the odd multiples of pi over 2. They are not the even multiples of pi over 2, because if you multiply, say, 4, which is even, by pi over 2, you get 2 pi. 2 pi's over here, and that's not one of the problem places for tangent. Okay, so it's the odd multiples of pi over 2 that are problem values for tangent. And so we would say here, all reals except the odd multiples of pi over 2. Now, you might see this fancy sometime. Okay, I'm just going to mention this. Don't panic. But sometimes we express odd numbers as being multiples of 2 plus 1. If you multiply something by 2, that makes it even, like multiply a whole number. I shouldn't say something. If you multiply a whole number by 2, that makes it an even number as a result. And then if you add 1 to an even, you get an odd. So you might see something like this, especially if you're looking online for other materials on your own, okay? That's a way to say odd multiples of pi over 2. And you could even put in a plus or minus here just to say, like, you can go around the unit circle either direction. If you hit those odd multiples of pi over 2, those are going to be your asymptotes, okay? The range is much easier for tangent because look at these little arrows. That means the function keeps going forever and ever. So this is just going to be all real numbers because tangent can go up, 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 and it can go down, down, down. It can hit any value, unlike sine and cosine. The period, as we already have noticed, is pi. This cycles every pi units. If you look at your graph here, on my graph, I have 1, 2, 3, 4 boxes to get to pi. And you can see that if you take any chunk of 4 boxes and just slide it over 4 boxes, it matches up with itself. That's the period. Now, amplitude, I'm going to put in quotes. The tangent function really doesn't have an amplitude because it doesn't have a max or a min, right? And so it doesn't have hills or valleys. But the quote-unquote amplitude we could think of as being this amount, okay? So the amount from the midline to that little quarter point is, in this case, just 1 unit, okay? And that's because there was no multiplier. So we are going to think of this. This really isn't called amplitude, but I wanted to try to make this as similar to the sine and the cosine thoughts that you had, okay? So from the midline to a key point, okay? This is our midline here on the x-axis, and going from that midline to one of these key points, okay, is going to be 1 unit on the parent function. Now that'll change if we have a vertical stretch, okay? All right, so there are going to be a bunch of different steps or components to finding variations on the tangent parent graph, okay? So the questions that you're going to have are going to have like slides and stretches and stuff like that. I wrote out these steps. The steps, you don't have to necessarily do them in exactly this order, but this is just a scaffold in case you do need that kind of help. So first thing, if you set the argument equal to 0, that's going to give you a starting point. So the argument is the thing inside of the trig function, pardon the parentheses. Then you find the period, and notice that for tangent, it's not 2 pi over b, it's just pi over b because we're dealing with tangent. Then you're going to find your convenient graphing interval by taking that period value, dividing by 4, and label your axes using that interval. Okay, so some of this should seem really familiar from sine and cosine life. If you have some kind of a vertical slide, I recommend drawing in your midline with like a little dotted line. If there isn't a vertical shift, the midline is going to be your horizontal axis. Then this part's a little different. The part in green, that's why I highlighted it. So take that starting point that you got up here, right, that starting point, and add or subtract your period value, and then that will give you a bunch of points on your midline. And that is going to be, those points are going to be equivalent to these points right in here. Okay, and then halfway in between those points, if you take any two of them, halfway between those points, that's where you put an asymptote. Halfway between these points, that's where you put an asymptote. Okay, so that's what I'm talking about here. Okay, you're going to have these points on your midline, and then we know tangent has asymptotes halfway between those intercept points. Okay, and then consider any vertical stretches for the quote-unquote amplitude, not really amplitude, but we can kind of think of it similarly. Okay, sort of like that. Okay, we're going to do one more example in this video, and then the other three examples are going to be in a separate video, just to break things up a bit for you. Okay, and remind you to take a little stretch break in the middle. Okay, so here, this example just has a shift. Okay, so you see that Mrs. Fry nicely wrote that for you, that this is an example of a shift problem. And I'm going to flip back and forth between the directions and how I do this, just so you can see how these directions help you. Okay, so the first thing is set the argument equal to 0 and then find the period. So I'm going to set this argument, the argument's the part in the parentheses, set this argument equal to 0, and that's going to give me a starting point. So that's what I start from. I'm also going to find the period, which is pi divided by b. B in this case is 1. There isn't a different multiplier in front of that x, so the period here is going to equal pi. So with that in mind, I think I am ready to commit to having my axis here. Okay, and the reason we leave this grid blank is so you can make those kinds of decisions. My starting point, I'm going to make that be here, negative pi over 4. And it said that my convenient increment is going to be found by taking my period and dividing by 4. So if I take this period and divide by 4, that means I would be counting by pi over 4. So that's what I'm doing, right? So I just kind of did that intuitively. So this box is pi over 4 wide. So this would be positive pi over 4. This would be 2 pi over 4 or pi over 2. This would be 3 pi over 4. And you don't have to necessarily label all of them, right? Just because you're counting by something doesn't mean you have to count, like label every single tick mark. So I might choose here to just do negative pi over 2 and negative pi, right? You don't have to label every single stinking one, okay? Up to you. All right, so I think we've done all of that. Label the axes, we did that. If applicable, draw a midline. Do I have a vertical shift? I do not. Okay, so my midline is going to be my x-axis. And then it says, go from your starting point plus or minus the period. So my starting point is negative pi over 4. The period was pi. So I'm going to have a point here, and then at pi units later. Okay, so now let's look. 4 boxes is pi. I can see that from going from 0 to pi. So 1, 2, 3, 4 boxes later, I'm going to put another dot. And I'm out of boxes going to the right. Let's see about going to the left. 1, 2, 3, 4. I can put another point there. Okay? And then the green stuff said halfway between these points is where I put an asymptote. So I'm going to put an asymptote here, which is at negative 3/4 pi. And then halfway between these two blue dots. So don't forget the axis. 1, 2 boxes would be halfway, so at pi over 4. And then let's see. So that from a dot to an asymptote is 2 boxes. So from this dot, 2 boxes later, there's going to be another asymptote. Okay, so that's kind of what I'm looking at. And then I consider any vertical stretches. Well, there aren't any because there's no number here. So I know that my key points are going to be halfway between the dot and the asymptote, I go up. And halfway between the dot and the asymptote, I go down. And I know this because of the shape of the parent function. See how those 3 dots are lined up like that? Up on the right, down on the left. So samesies for the graph that I'm making here. There wasn't a flip. That would be the only way that would change. Okay, and so I'm up on the right, down on the left. And then I'm going to hug the asymptote, curve in. And hug that asymptote and curve in. And hug that asymptote and curve in. Okay, but there's no more space. Okay, so that's kind of my shape. And I'm going to think about this for a second to make sure it makes sense. So this shift was pi over 4 to the left. Does it look like that's what happened compared to this? I would say yes, because that point just went over here, this point went over here, right? So that would be a shift of pi over 4 to the left. Okay, so now these questions are kind of tricky, right? So before, some of it is going to be easy. Okay, let's do the easy ones first, actually. So our quote-unquote amplitude, which isn't really amplitude, but the distance from this midline up to these key points or down to these key points is still 1. My period was still pi. I found that out up here. My range is still going to be all real numbers. That's a short way to write that. That symbol means all real numbers. My domain is going to be a little trickier. Okay, so I'm going to just name one of my asymptotes. And then my next asymptote is going to be the period length away. So I could add or subtract that period as many times as I want to. Okay, now this is a little bit weird to think about, right? This way of writing it maybe is uncomfortable to you, but you could write it in English. You could say pi over 4, and then like what I'm saying right now, you could literally write this, quote, asymptote at pi over 4, and then more asymptotes every pi units later, end quote. You could write that English. Okay, so if this is uncomfortable for you, feel free to express yourself using the English language. Okay? I'm going to come back in a second video, and that video is going to basically just start out with asking you to pause the video. So if you would like, what I would recommend doing next is just go ahead and try examples 2, 3, and 4 on your notes packet, and then the video is going to go through the answers. Okay, so that's where we're going to pick up in the second video.